Now we're looking at the perpendicular bisector theorem. Perpendicular bisector theorem tells us that if we have a perpendicular bisector, in this case, we know that BD is perpendicular to AC, and also that it bisects it so that AB and BC are equal. Well, what it also says is any point that is on this line will be equidistant from C and A at the same time. So it'll be equidistant from the ends of the vertex. So in this case, we know that DC and DA are going to be equal because D lies on the perpendicular bisector. So we can state that these two sides are equal. Our equation is 5x equals 3x plus 14. Sorry. We're going to subtract 3x from both sides. We get 2x is equal to 14. Dividing both sides by 2, we get x is equal to 7. Oops. Let's try that again. 7. We want to find out what AD is. So AD, according to the picture, is equal to 5x. So in this case, it's 5 times 7, or 35. So again, we know AD and CD are equal because of the perpendicular bisector theorem. We plug in our values, we solve for x, and then we plug it in and we get AD is equal to 35. Now for this next one, we have two questions. We want to know what segment lengths are equal, and we want to know if V is on the line WX. Remember, the line WX goes on forever, so we want to know if this continues. Well, and it does it go through? So first of all, things that are congruent. We know because this is a perpendicular bisector, we know that those two lengths are equal. So XY is congruent to XZ. We also know that these two lengths are equal because they're given to us. So we can say YV is congruent to VZ. And finally, we can say that YW and WZ, are equal. So YW is congruent to WZ. The reason why YW and WZ are congruent is because this point right here lies on the perpendicular bisector, so therefore these two segments will be congruent. Now it asks if V is on WX. If we look, the distance from V to Y, so VY, as we stated before, is congruent to VZ. Okay, so these two lengths are equal. The converse of the perpendicular bisector theorem tells us that if a point is equidistant from the two ends, so V from V to Z and V to Y, if the distance from this point, it's equidistant from the endpoints of this segment, then we know that it lies on this perpendicular bisector. So the answer would be yes, because VY and VZ are equal. And again, we know the two lengths that are on the segment here, the perpendicular bisector cuts it in half, so XY and XZ are congruent. W is on the perpendicular bisector, so WY and WZ are congruent. And then, of course, it shows VY and VZ are equal. And for the second part, because VY and VZ are equal, V is equidistant from Y and Z, so therefore V has to be on the perpendicular bisector. Alright, here's another problem. Again, we know that JK is a perpendicular bisector of NL, so we know these two lengths are equal. We also know that these two lengths are equal because of the perpendicular bisector theorem. So it says, are the segment lengths equal? Yes, and it would be because of the perpendicular bisector theorem. So that's the reason why. Oh, what segment lengths? I'm sorry. I'll back that up. Oof. So what segment lengths are equal? Again, Mn congruent to Ml because it's given. Nj is congruent to JL because of it's a perpendicular bisector. Oh, we can just say segment is bisected. How about this? Even better. NL is bisected by JK. And then finally we can state NK is congruent to KL because K is on line JK and therefore the perpendicular perpendicular bisector theorem. So that tells us that the perpendicular bisector theorem tells us that this point, since it's on the perpendicular bisector, it makes those lengths equal. So again, NJ and LJ, so NJ and LJ because it bisects it, NK and LK because of the perpendicular bisector, and the diagram shows that part. Now we need to find NK. Since we know these two lengths are equal, we can state that 6x minus 5 equals 4x plus 1. We're going to subtract 4x. (2x minus 5 equals 1). Adding 5 to both sides, we get 2x is equal to 6, and dividing both sides by 2, x equals 3. So now we take that and we plug it into NK here. So NK is equal to 6 times 3 minus 5. So we get 18 minus 5, which equals 13. So we get 13 there. And why is M on JK? We talked about this just a minute ago, I think. It's the converse of the perpendicular bisector theorem. So because Mn is equal to Ml, that tells me, because of the converse of the perpendicular bisector theorem, that M has to be on JK. And again, since ML and Mn are equal, M is the same distance from N as it is from L, and the converse of the perpendicular bisector theorem tells us that M is on the perpendicular bisector. Okay, and that's it. Thanks.